Chapter 11 is about the mechanics of capital budgeting, the metrics we use to evaluate potential investment projects. In the full chapter, we'll cover 5 methodologies: net present value, internal rate of return, modified internal rate of return, payback, and discounted payback. While one method, NPV, dominates, all 5 provide information about the viability of potential investments. In this first part, we focus on the 2 primary metrics used, NPV and IRR. Capital budgeting is one of the primary functions of the finance function in a corporation, and a very important one. Capital budgeting can involve a new product, a new piece of machinery, a new facility, or an acquisition. The decision to take or reject can determine the long-term strategic direction of the firm. Besides the strategic importance, capital budgeting projects typically involve large sums of money and would be difficult or impossible to reverse. Here are the 5 steps involved in capital budgeting analysis. Number 1, estimate the cash flows. That's Chapter 12. Assess their riskiness. That's also Chapter 12. Find the weighted average cost of capital. Chapter 10. Find the NPV and IRR. Chapter 11. Decide accept or reject. Chapter 11. And here are the 5 techniques we'll learn to understand and employ in this chapter. We're going to start with NPV and IRR. An independent project is one whose cash flows do not affect any other project. If 2 or more projects are mutually exclusive, taking one automatically precludes taking the other. For example, the decision as to whether to build a plant on a plot of land or sell the land are mutually exclusive. You can do one or the other. If projects under analysis are independent, a firm can choose all, none, or any subset. Why is this important? If a group of projects are independent, then we only need to decide go, no-go on each one. If the group is mutually exclusive, then we must be able to select the best project, the second best, etc. We must be able to rank them. And as we'll see, not all evaluation methods are capable of ranking. A project with normal cash flows has one outflow, an investment, at time 0, followed by a series of positive inflows for the life of the project. One change in sign from time 0 to time 1. A non-normal cash flow stream has 2 or more changes in sign. The example given is a strip mine, when the land must be reclaimed when the mine is exhausted, causing a large negative cash flow at the end of the project. Net present value is the dominant capital budgeting evaluation metric. Technically, for a normal cash flow project, it's just the sum of discounted inflows netted against the time 0 investment. More generally, this is the main use for the cash flow worksheet in the TI Business Analyst too. This is what it's made to do. Here are 2 sample projects we'll use to demonstrate the various methods. Project L is a long-term project in the sense that its cash flows start small and build. Project S is the opposite. Its cash flows start with a bang in year 1 and decline. The column change in cash flows, we'll be using that later. Looking at Project L, here is the calculation of its NPV. Discount each cash flow and add them up. Since cash flow 0 isn't discounted, its value remains the same. Each successive cash flow is discounted by dividing by 1 plus the cost of capital raised to a power equal to the period. So the year 2 cash flow of $60 is divided by 1.10 squared. Note the Excel function example. Excel has an NPV function with a slight peculiarity. Cash flow 0 cannot be included in the range inside the function. It has to be handled outside. Look carefully at the example. We'll be covering this several times to reinforce it. Apparently, NPV was designed this way originally in Excel, and it can't be changed now. This shows Project L's cash flows placed on a timeline and discounted. Project L's NPV, $1879. Looking now at Project S, we find an NPV of $1998. Since this calculation is perfect for the TI Business Analyst 2 cash flow worksheet, we'll work through one. I suggest you get your calculator and follow along. As mentioned in the TVM chapter, familiarity with the cash flow worksheet operation is important. In your calculator, press Cash Flow, Second, Clear Work. With CF0 displayed, enter 100 plus or minus, press Enter, and the down arrow. Remember the pattern from the TVM lesson and the video. With CO1 displayed, enter 10. Press Enter and down. With FO1 is equal to 1 displayed, press Enter and down to accept a frequency of 1. Repeat for all cash flows. When all cash flows are entered, press NPV. With I equals 0 displayed, enter 10, press Enter and down. With NPV equals 0 displayed, press Compute. Try it out to be sure you get the correct answer, 1878. If the present value of a project's inflows exceeds the initial investment, then the project should be accepted. If the projects are independent, then all projects with NPVs greater than 0 should be accepted. If the projects are mutually exclusive, NPV can be used to rank. The project with the largest NPV is the most desirable. In our example, the NPV of L is 1878, NPV of S 1998, so NPV S is the better project, but both are acceptable. NPV meets all the desired criteria for a capital budgeting method. All the cash flows are considered in the computation, meaning we use all the data we have. TVM is considered. NPV can be used to rank mutually exclusive projects. NPV is directly related to the value of the firm. In theory, if a project is accepted and pursued, the value of the firm will increase by the amount of the NPV. NPV is the dominant method. It always prevails. If other techniques give conflicting accept-reject decisions, NPV is the final word. Closely related to NPV is the internal rate of return, or IRR. IRR is the discount rate that makes NPV equal to 0. And while it's possible to solve for IRR manually, it is iterative, meaning you try values till you hit the answer. There's no closed-form solution. Much easier to use your financial calculator or Excel. In the TI Business Analyst 2, enter the cash flows just as you did to solve for NPV. Or if you just solve for NPV, the values are still in the CF worksheet. Instead of pressing NPV, press IRR and then compute. In Excel, the IRR function allows you to enter a guess, but it's not required. And the IRR function does expect the entire cash flow range, from CF0 to the end. Looking at the NPV and IRR formulas together. With NPV, we solve for a dollar amount. With IRR, we're solving for the root of a polynomial of degree n, a percentage. For our project L, the cash flow should still be in your CF worksheet from the NPV calculations. Simply press IRR and compute. After a very slight hesitation, the IRR is displayed. The internal rate of return for project L, 1813. Repeat for project S to find an IRR of 23.56. The decision criteria for IRR is simple. If a project's internal rate of return is greater than the firm's cost of capital, accept the project. If less, reject it. Note that if projects are mutually exclusive, they should not be ranked on internal rate of return. Why? Project S has an internal rate of return of 15%, but an NPV of $1,000. Project Y has an IRR of 10%, but an NPV of $1.5 million. Which would be a better choice? Why? NPV dominates. More money is better. Internal rate of return does have several strengths, not the least of which is that it's preferred by executives who appear to like a percent return. It does consider all the cash flows and time value of money, and it does provide some indication of risk. Consider, if the IRR of a project is 15% and the firm's cost of capital is 10%, you've got a lot of leeway to make errors in cash flow estimation and still have a profitable project. If the firm's cost of capital is 14%, not so much. IRR does, however, have some serious flaws. As shown, you cannot use it to rank mutually exclusive projects. The two issues that we'll explore in more depth are the problem of multiple answers and the reinvestment assumption. Before you go further, take the time to view this video tutorial. It walks through finding NPV and IRR in the TI Business Analyst 2 using the CF worksheet with the calculator simulator on the screen so you can follow the steps. This ends our coverage of the first two capital budgeting methodologies. In Chapter 11, Part B, we'll cover modified internal rate of return, payback, and discounted payback.